Welcome everybody, my name's Scott Hebbard from Spark Systems, and today we're looking at business rules and decision tables in Enterprise Architect 16. Our presenter today is Phil Chudley. Phil is a principal consultant at Dunstan Thomas, based in Portsmouth in the UK. He's been using Enterprise Architect for 17 years, which is even longer than myself. Proficient in UML, BPMN, Archimate and SysML, and developed and delivered Enterprise Architect training in the UK, Europe and the Middle East. Phil specialises in extending Enterprise Architect using MDG, scripts and add-ins, and has presented at various Enterprise Architect user groups in the UK and Europe, and has also recently presented at the Enterprise Architect Global Summit and at previous summits in the past. So please note, for the presentation today, audio is muted for all participants. You'll be able to type questions to the host, and if we can't answer questions live, we'll follow up offline. So simply enter text in the text box on the right hand side of the screen and hit send or hit enter on the numeric keypad, and that'll come through to myself, and we'll cover questions at the end. But right now, I'd like to hand over to Phil, who is going to present on business rules and decision tables in Enterprise Architect 16. So thank you, Phil.
Many thanks, Scott, and let me extend my welcome to everybody who is joining from wherever you are in the world today. Okay, so what we're going to do is give you an overview of business rules, decision tables, how they can be represented in Enterprise Architect 16, and generate some Java code and integrate it with some state machines. First thing, just a little bit of background about what decision tables are and why we want to use them for modeling business rules. Now, businesses throughout history have all had decisions to make, rules to follow, things to do, and these can be quite simple and they can be reasonably complicated. So various ways of representing business rules are decision trees, which we can represent using a flowchart-like notation, EA flowchart, UML activity, business process model notation 2.0, etc. Or we could use a decision table, of which there are two types, and I'll go through those in a moment for you. And they could be modeled using something known as decision model notation, or DMN for short. This is a decision tree. Now, it is symbolic. Basically, it's a series of nested if statements. So if something's true, do this. If it's not true, do that. Multi-decisions to make. And depending on which decision you have, you go through the various branches. And even in this simple symbolic representation, you'll see there are many, many paths through this. Now, the advantage of this is most people understand it as a flowchart. It's quite a well-known symbol set. The difficulty is maintaining it. It's not that easy to maintain. And yes, you can generate code from it, but is that straightforward? Well, I'll leave you to decide that question, or the answer to that question. So yes, you could do it using that, but there's a more concise way, or potentially a more concise way. This is known as a decision table, on which there are two types: limited entry or balance, and an extended entry, which we'll come on to in a moment. Now, let me dispel a couple of myths. Some people may be say, oh, decision tables, that's a new feature. Well, it's fairly new to EA, yes, but it's been around for an awful long time. Just for interest, I first came across decision tables when working for International Computers Limited, ICL, in the UK in, wait for it, the 1970s. Yeah, and where we had a product called FileTab. Now, if anyone's in the UK with a long memory, you may remember it. And this was decision table, and it worked very similar to this kind of table. It input the rules, input the data, and tabulated the results. hence the name FileDAB. So the way to interpret this is we have a number of conditions, we have a number of actions, and the conditions in a limited entry are simply yes, no, or don't care. In other words, it could be yes or no. And the combination of yes, no, yes gives you these actions. So no, yes, no, do this, do this, do this, etc. And that is the original version of a decision table. You could model that in EA using the tables and custom tables, but we're not going to do that. Nah, we're going to do something a bit more interesting. This is an extended entry decision table. This is where instead of simply having yes, no, you specify inputs. So we have, this is a very simplistic decision table about calculating an insurance premium for a car. Now I've trimmed it down. In the real world, this is going to be a little bit more complex, obviously. But this simple example will serve perfectly well for today. So we have an age. Now notice, rather than just say, is the age 17? Yes. Is the age 18? Yes. No, we just say, well, we have a range. Let's say 17 to 25. We have various types of vehicle that we are able to insure: saloon, SUV, sports. In the UK, we have something called a no claims discount, which if you haven't claimed on an insurance over a period of years, you get a discount in the premium. So here is, it's called NCD. So here we have 0, 1 to 4 years, 5 to 8 years, and so on. And then, of course, if you've had driving offences, speeding ticket, running a red light, hopefully not driving under the influence because you wouldn't get insurance anyway, but using a mobile phone, any of these kind of offences, it will affect the premium. So I've just simply got a no yes, just to keep it nice and simple. Notice we've got grouping here, so that applies to all of those. This applies to all of those. And then individual results. So if we're between 17 and 25, we want to insure an SUV, we got a no claims discount of 2 years, we have no offences, then we are going to have 550, right? So that is a simple example of a decision table written in pure text or Excel format. So we're not going to do that. We want to use Enterprise Architect, don't we? Of course we do. So in EA, there is a technology, an MDG, which allows us to model a decision table, not just the table you saw earlier, no, other bits and pieces which fit together so that you can actually execute the decision table, put data in and see that it's working. And if you wish, you can generate Java code. You can also generate other languages, and if my memory serves me correctly, that is JavaScript, C++, and C#. Although, personally, I haven't tried those variations. So the question in your mind may be, well, why would I want to generate Java code? Why don't you just run it in EA? Well, yes, you could. But the benefit of generating Java code or other language is you've got a code set. Now that code set will be guaranteed to give you the results if you basically follow what we're doing today. And then you can take that code, put it into your application, saving you development time. You want to modify the code, you just simply go back, modify the decision table, regenerate the code. So yeah, that is the benefit of why we would generate the code. Now, there are prerequisites. Now, the prerequisites are you've got to have the perspective that includes MDG, DMN. There are other things in the perspective as well, which I'll show you in a moment in EA. You've got to have the complete JDK, not the JRE. That won't work. You've got to have the complete JDK, which is, as you well know, available free of charge. And you have to set a path in EA known as the Java home. And we can show that where is. And there is a code engineering toolbar on the EA workspace, which controls which languages your objects are set to. And that is Java by default, but I always have this toolbar exposed so I can control the programming language myself. So that's the prerequisite. Now we have a workflow. Now the workflow is quite critical. You can't just chuck stuff on a diagram, do a few relationships and expect it to work, because it won't. You have to do it in a sort of incremental way. And so you create the diagram, you define inputs, you add an input data, bind those together, model the decision table, you then invoke the decision table, bind all that together, validate. If you wish to simulate it, you add a simulation element, create some test data sets, run the data set, and generate the Java code. Right? Now that is fairly time consuming. So let's put things in perspective. Today, unfortunately, I could not generate an example from a blank sheet of paper. There's just no, we don't have enough time. So what I've done is I've generated an example based upon that little car insurance, which I will open for you in EA and then take it apart and show you what is there. And yes, the repository will be made available, and we'll tell you how you can get it at the conclusion of the webinar. So without further ado, let's now go into EA. And we should be looking at EA16. So I'm using EA16 Ultimate Edition 64-bit. And so that you can verify that the prerequisites and what you need as a prerequisite is, if I look at the perspectives and I look at my own perspectives here. So here is a perspective which I've labeled a DMN ESM, Decision Model Notation Executable State Machine. So if you are doing decision modeling, you'll need DMN 1.2. Right, but pretty much that's all you need. But we're going to up the ante. We're actually going to combine the decision table with executable state machine. So if you need an executable state machine, you'll need basic UML, class, state machines, and executable state machines. So that's the bare minimum, DMN, the full Monty, all those guys. Right, that's that done. The code engineering toolbar is set to Java, so we're all ready to go. So let's analyze what we need to do. So here is my model, and here's my decision table model. Now, this is a diagram provided by the DMN MDG, and as usual, it's got its own little toolbox. So I don't need to tell you how to put stuff on a diagram because you already know. So let's have a look at what you do first. Thing you do first in a decision table is create what are known as item definitions. One item definition per input to your decision table. So I got age, I got car type, I got no claims discount or NCD, and offenses. You do not need to put anything inside here like attributes, just a plain stereotyped class here. Right. These will eventually turn into Java artifacts. So the advice is not to put spaces in the names. If you do, then the code generator will replicate, it will replace the spaces with an underscore, but I just keep things nice and neat. Then there's this rather strange thing called an owner, which is called I've called it T quotation data. Now, it's just a habit I got into by prefixing this data set by T. This owns this and this and this and this. Now, you'll notice there's no relationship between them. There's no composition, nothing like that. But, and this is a really big but, it's really important, this. In the browser, the structure of this item definition called T quotation data has children in the browser structure. If you do not have this structure, which you won't get simply by drawing it on a diagram, you will have to do that. Of course, that is a gotcha. You may easily miss that out. So that is the first thing you need to do. Step one is completed. Now we go up the model a little bit, and we have this guy. Now this guy, if I find it in the browser for you, is an input data item, an input data element. And this input data element is like a go-between this data and the decision table simulations. So you just create this, which is no real problem. But then, and this is the important part, you need to bind this to this. So if you double click this, it opens up a DMN expression. Now, if you click, because I've done this so it's all pre-populated, but if you did this and it's not populated, you're doing this from scratch, you'll see that these fields would not be present. So the first thing you need to do is to bind it, which is this toolbar here, which opens up the all too familiar select element, select package, select diagram, dialog you see many times in Enterprise Architect. So this, you choose your top level owning data item here, T quotation data, and click OK. Right. Then using this window here, the navigation window, you can actually set the type of data, right, and the values it can take. So on the T quotation data, if I look at the contents of this, this is the type of data. So we have various types of data we can use: string, number, Boolean, date, etc. Now I've kept it to a minimal type of number and string. Over here, we have values. These are optional, but notice this one here. Well, I appreciate the text may be a little bit small for you to read, but I can read this out. When you have a string, you can set up a comma delimited double quote string set. So I have saloon, SUV, sport, no, yes. So yeah, you're setting up an enumeration. Exactly. The advantage of doing this is that EA is very clever when it comes to entering the decision table and other items which we'll come to. It actually got predictive text. So if you've got these enumerations, they will become predictive text in other bindings, as we'll see a little bit later. So now we come to the main part. Now, I will stress there's more than one way of modeling decision tables using DMN. This is just one such, one such arrangement. In the Sparks user guides, the library of PDF documents, and in the EA example that ships with EA, there are other versions of decision table, and you can explore those at your leisure to see other arrangements. But what I've got here is a typical arrangement. This is the decision table element itself, and this is a decision element which basically links the data to the decision table. So I double click that. Now, here is the decision table. Now, this takes a fair while to create, but it's not tricky by any means. You create a column for each input and a column for the output. I believe it's possible to use multiple outputs, though personally, I haven't tried that. This is the data that you are putting into the decision table. And as you enter into the decision table, you can set the input parameters here. So the input parameters are corresponding to the names that you have on your input data set, which we looked at previously. You then work your way through row by row, and the syntax is, for a discrete value, it's just the integer. Easy. For a range of integers, it is, in fact, open bracket, square bracket, that is, n colon dot dot or full stop m. For an enumeration, it's, you just type a value in the enumeration, and finally you have the result, which is the premium, which is paid according to the combination of the inputs. And that's it. So that is the decision table. Now, as a visual aid, you can, if you wish, merge the common rows using this little toolbar, and it makes it look like that. It's a matter of opinion whether you find that easy to read or not easy to read. I'll leave you to decide that for yourselves. It doesn't make any difference to the underlying decision table, and it doesn't make any difference to the actual execution or simulation. Right. The final piece of the puzzle, is this decision element called the quotation, which, if I double click, will have to be bound as well to the decision table and its inputs, and that is done here. So essentially, you connect that to this business object here, and you can see it puts items in here. Now, that's not the end of the story, okay? There is a little bit of extra work to do, and this is when you want to simulate the decision table. So to simulate the decision table, what you will do is you will use this area here. I'll just get it right. Right click and edit the expression. I'll do that again. You right click, edit the expression, and the expression is written in a language called FEEL. Now, this is going to catch your object-oriented programmers out, because the notation is owner space dot space value. So here you'll see there's a space either side of the dot. Well, and this basically says that the input, the decision table, is quotation data age. That's it. That's all it says. And you have one of these for each of those data inputs. If you are going to generate Java, then you'll need to put the Java expression in there. I haven't done so. It actually still works, but it's, you can put the Java expression in there as well, which of course is going to be quotation data dot age. Okay, so that's the edit expression. So now we are ready pretty much to go. But there's one important thing you need to do. There's no point you generating code or simulating the decision table unless it's been validated, which we can validate this here. It validates the table. And you'll get one of three scenarios. A, nothing. It will say, yeah, it's done. Perfect. 0 errors, 0 warnings. You'll get warnings, which in my case says, I don't have a rule where the age is over 25, which is actually perfectly true. I don't. It won't affect your simulation unless, of course, you put data in where the age is greater than 25. If you have an error, that is, you've got a syntax error somewhere in the entries of your decision table, you've got to change it, because obviously nothing is going to work if you've got errors in the actual entries to the decision table. So we're happy. It's all been validated. Now, the next thing you're going to do is put a simulation entry into the model, and that is then bound to a package, and that package is where the model itself is located. So you don't have to have this element in the same package as your decision table, but I chose to do so. Right. So without further ado, what we need to do is to create some data sets for this. Now, let's just look at the data set. I'm just going to do that. So the data set is, let me get it right. Let's move on a bit. Apologies for that. I got a little bit lost. I said it was a bit complicated, but anyway, we got this item here, and we're ready to go for our actual simulation. So the input data set. Yay, got it. Sorry. Yeah, so basically, because we've got so many elements on here, I just clicked the wrong one. Easy mistake to make, even for someone who's experienced in EA. So this is the data input here. We click that, and there you'll see there's data sets. Now the data sets are, we're back live now, we have many data sets that we can create, one for each kind of simulation. And you get a default data set, which you cannot delete. You cannot delete that. So the idea is you pick a section of rules and you set up the data in here according to what you want that test to be. So here, my rule 1, I'm testing rule 11, which is age 20, a saloon car, 2 years no claims discount, but we've got driving offences. And you can create as many of those or as few of those as you wish. So I got a number of these already created. All right. So having done that, we can go back to the simulation here, and you'll see there is a drop-down list. Now, I'm going to put my life on the line here and say to Scott, choose one of those at random. Don't choose default, please, but choose any of the 11, 15, 16, 19, 2, 6, 7, 8 that you wish.
I like number 7, so we'll say rule 7.
Number 7. All right, so let's say rule 7, and we simply run the simulation. Now, notice what's happened if I just minimize. there on the screen, this is the input set. And if I scroll up, there is the result from the decision table. Now, is it correct? Rhetorical question. Well, if I go into the decision table, rule 7 is 700. So, yes, we validated that our rules, our test data set does in fact work. Great. So now I can end the simulation. One thing that will sort of puzzle you is you've got to keep changing the screen down in here in this window so you actually interact with the right object. Practice does make perfect. So I should stop the simulation. It will stop it. Here. So stop the simulation. Nice and tidy. Now, the generation, the code generation, I won't actually generate the code because I've actually already generated it. But if you look at here, generate module, right? It is very picky about where you put stuff. So there is what is known as reverse domain name in Java. So this module path, which you'll see here, is created by yourself using File Explorer, and that's the path you do. So there is a navigation here, so you can open up the path and create the path. But it is very picky. It has to be there. If that path doesn't exist, you will get an error message in the generation. So to generate the code, you simply just click generate, select Java, and you click generate. And there we are. Now, it happened lightningly fast because the compiler is pretty quick. Now, it says here, DMM module is successfully generated. That is what you're looking for. You may see deprecation warnings because Java is fluid. So don't worry about that. So now we've generated the Java code. We're all hunky-dory. We're perfect. Generated Java code for a working state machine. Now we can go on to the state machine part. Right. So I'll close this diagram down. I don't need it anymore. And although when I built this up, I built it up incrementally to save a little bit of time today so we don't run the risk of missing anything out, I'll do the actual item. I'll just open up the diagrams immediately for you. So what we have here is a Java class with a state machine. Now, this state machine is quite straightforward. And if I open up, where is it? Where I'm looking for it. Oh, here we are. Yeah. So, this is the one I'm looking for. That one. So here, if I zoom in on slightly, right, you have a simple state machine, which is basically initializing, which I say is mimicking the states to acquire data from a user. We have a transition go, which goes into an acquiring, and just for fun, I've got a substate here, and this operation, which I'll show you in a moment, is the one which is actually going to link to the decision table. And we're filling in all those blanks in a moment. So you don't have to have this link to the decision table to test these states. But we'll show you how you execute this in a little while. So let's go back to the actual class itself. Here is the Java class. We'll zoom in on it. Now, one thing that is a little bit odd for you Java programmers is you create attributes. Oh, sorry, I think I am still here. Can you hear me now?
Yeah, I can hear you now. I think you just got muted, and
Yeah, I
probably-
think the button on my headset got clicked. I do apologize. So back one. Here we go.
So
The
you're up to the
attributes.
attributes.
Yeah, attributes are public, not private. Then we have two operations. This one, if I open up and simply look at the code, that is simply a call to this operation, which integrates with the decision table and returns a value. Right, that's it. This one is the heart. We have this is an application, an operation, which is then connected or bound to this DMN symconfig. So this DMN symconfig is exactly the same as you saw previously. And then it's connected with a dependency and bound to this operation. Now, the tricky bit. If you look at the code, I think I can zoom. I can't read. That's okay. I can zoom in on that code. Now, this should be code complete, but it doesn't. It's not complete code complete, if you get my drift. This quotation calculation is the Java class for the actual decision table. But if I use that like that, and I put a dot after it, I don't get the data item. Now, that puzzled me for ages to work out this syntax. But the syntax is quite easy. This is the name of the simulation. This is the name of the input item that we saw earlier. And this is the name of the data. So it's ... So once you got the pattern, it's very straightforward. And then you return get quotation, which is an operation generated in Java when we generated the decision table. Perfect. So that's all the building blocks. And then in the state machine, that's the wrong, that killed that diagram, that one. This do apply, that one there. It simply pulls the operation defined in the Java class called this dot get quote or get a quote. Perfect. Okay, now on to the fun part. Now let's just kill a few of these diagrams down and let's have a look at the actual simulation itself. So what you have, and I zoom in on this, is an executable state machine element, which you can take from this simulation section of the toolbar. You then reuse your Java class as a property in here, which gives you an instance of that Java class. You can then give it a name. Give it a name. What you can then do is right-click this, go to the features, and set the property values. So these property values will be the same as the input data sets that we used to test the decision table, if you're with me so far. Of course, you could put other data in there if you wish. So that is a test of one input for this decision table. So does it work? Well, let's find out. To prepare ourselves, what we need to do is go to the simulate ribbon and open up what are known as local variables. And you'll see this spring into action in a moment. Okay. So then what we do, excuse me, is we open up the events window and the simulate, and then we go to simulation and state machine, blah, and then you say generate, build, and run. Or if you've already generated the code, you can just skip to run. and the state machine begins to execute. Whew, thankfully. Now, one thing that really, really puzzled me is I've done a fair screen sharing is now paused. No, stop. So what I've done in the past is use state machines in JavaScript. And in JavaScript, you get a little section up here giving you what triggers you can choose. But it doesn't appear in Java. And I thought, well, how on earth do you fire the trigger? And I couldn't work it out. Eventually, I think with a lot of digging into the Sparks help systems and user guides, I found out if you type the word, and I'll have to type it correctly, otherwise nothing will happen, broadcast, and then the name of the trigger, it fires the trigger. Yay! Now, this is where it gets interesting. If I have a look at the local variables, I see a local variable called driver, the instance of my Java class. If I expand that, I see car type SUV, age 23, no claims discount 0, premium 600. Ah, now you're saying, okay, prove that is the right answer. All right, okay. You asked for it, you will get it. So now here is the decision table. So if I look for an SUV, age 23, so that's SUV, 0 no claims discount, no offenses, 600. Yes, brilliant. So that is giving me the right answer. So I've invoked the state machine with, sorry, a big decision table within the state machine. So you say, why? Well, that code, the state machine, can also be used in my application. I just add a UI on the front, accept the data, pass it in. Right. So this was just to prove that the integration works, the code works, and everything is nice. So
Bill,
we don't want to leave. Yeah.
Can you click on the simulation events tab for me too, just to so sometimes the triggers and sequences appear there as well with rating triggers.
But I couldn't get them to appear in Java at all.
Right.
Okay. Yeah.
No
So
problem.
now, okay. So now what we can do is we can now broadcast back and quit. Yeah. Now we've exited the state machine nice and easily. So I've just got a couple of more things to do, and then we'll draw things to a conclusion. And if there's any sort of questions we can answer immediately, then certainly we will. Let's do something a little bit more adventurous. We can simulate one data set, like this. Whoops, I've lost it. There we are. Oh, there we are. One data set. But that's going to be really tedious to go if we want to exercise a large decision table. Oh, that's going to take ages. We don't have to do that. Because we're using instances of our Java class, we can simulate simultaneously more than one. So here I've got 3 instances. So if I simulate this, watch what happens. It says on here, which I'll just zoom in ever so slightly for you, driver 3, driver 2, driver 1. So it's recognized there are 3 instances. To run them in parallel, I broadcast go. Now in the local variables, instead of having 1 instance, we got 2. So for driver 1, the premium is 1,000. Trust me, that's the correct answer. Driver 2, we have the premium of 900. And for driver 3, who is uninsurable, I've got a ridiculous amount of money. I mean, in a realistic situation, I would return something like not eligible rather than £10,000. Or, you know, but it was just to show that it will handle all of the entries. So there is one thing which I will try, but it wouldn't work this morning. I'll be absolutely honest with you. I have got it to work in the past, and it may be something that I'm not quite entering correctly, but as I say, I'm still learning this. I'm just sharing you my experiences and my research onto this. The question is, well, that's fine, but supposing I didn't want to execute them in parallel, well, you can run this and you should be able to use a send. So if you say send, go to.
You've typed SNED.
So I have. Thank you. I was looking at my keyboard and not the screen. Then go to driver. Thank you very much for that. Driver 1. Right, if I got that, it says driver 1. Oh, thank goodness it worked. So all it's doing is it's stimulating driver 1. So driver 2 has got a premium of 0 because it hasn't got the premium calculated, but driver 1 has got the premium calculated, which should have. There are some issues. It doesn't always seem to work. And of course, today, guess what? It wouldn't work, would it? I'll just do one more of a different one. So I just sent it to driver 2. And it sent it to driver 2 and driver 1. So that has worked. It actually sent, why it sent it to driver 1 and driver 2, I don't know. Possibly because I sent it to driver 1 first and it executed it, sent to driver 2 and it added it to the simulation. But you have to play around with that, all right? But yes, that is how we actually bring everything together. However, it would be very remiss of me not to tell you something which is probably in your mind. So before I get to that, let me just tidy this up and get out of all of this. And I'll go to broadcast back first and then quit. Right. And that's all very good. But decision tables aren't fixed. So the question would be, if I change the rules here, like that, and then I regenerate the Java class for the decision table, which will work, and I reran the simulation exercising these new rules, it doesn't work. There's a slight issue. Now, I don't know if this is by design or it is a flaw. So I have to go back to the developers, Scott, but trust me, it doesn't work. It uses the old version of the decision table. Now, let me just explain very briefly why. So if I do need to share my, so there is Windows File Explorer, and this is the set of data that you get generated. Now, there's a file in here called simulation output. Now, this folder is created if it doesn't exist by copying the code from the generated decision table, right? So the first time you generate the code for the state machine, that folder is created and the classes are copied across. But on subsequent changes, as this folder exists, it doesn't copy the code across from the decision table. So if you do change the decision table, go in here, delete that folder, just send it to the recycle bin, regenerate the state machine. It will pick up the latest version of the decision table and all will work. Now I can verify that because in the system output, it says something in here. It says if exists RM Dyer or something. Anyway, that is how I discovered it, and just pass that on. So let's go back just very temporarily to the PowerPoint. I must admit, I did skip some PowerPoint slides because I wanted to get everything in. The PowerPoint slides we didn't see are just the workflow, the executable state machines. But what I'd like to do before questions is, this is quite complicated, and by demonstrating it on a pre-built model, you may still have issues, questions, puzzles, and so on. So what I'm going to make available to Scott after the webinar is a document which I created. It's about 50 pages, and it's a step-by-step tutorial on exactly how to create the example I've just demonstrated for you. So if you follow that step by step, and there are no, it will create the example for you as I have demonstrated. And that will make that available. And Scott, I'll pass over to you in a moment to say how that can be made available to the audience, so that you can download that. That will give you a full explanation of what you've demonstrated and the opportunity to generate it yourself. We'll also supply the QEA file of the repository, which I've just used for the demonstration. I won't be able to give you all the folders. So if you did do this yourself, you will have to set your own paths. You will have to set your own class paths. And that is why you'd need the repository and the Word document. I would suggest you do both. Otherwise you can't just run my example on your machines, because all the class paths will be wrong, all the paths will be wrong. And so that is the resources that we'll make available to you. So apologies for the slight hiccup in the middle, where we got slightly lost along the way, but we recovered. These things are sent to try us. Hopefully that didn't detract from the value. And the objective is to give you insight as to what Spark Systems EA can do in decision tables, pique your interest so that you can have a look, investigate further, and have a bit of fun with it. So thanks very much for your attendance today. It's been my pleasure to produce the webinar. I hope it was beneficial to you, and I value any question. We've got a few minutes to do a few questions. So if there is anything that's pressing, Scott, we can do it. Otherwise, we'll do it offline.
No worries. Thanks very much, Phil. And look, you were able to have decision tables and rules for a complicated insurance system, and to simulate out 3 different instances and produce results, which in the past, if it was hand coded, would take 6 months to do. So the fact that it was a bit tricky to remember where the input was is no big deal. When you're saving
that.
hundreds of hours.
Yeah, appreciate it.
So we've just got a couple of quick little questions. Now, there's one that I might answer that says, are there plans to include decision tables in documents? And with there's a new feature in 16.1 that can output some of your diagrams in a scalable vector graphic format, so that can be easily included in reports. So that's something to keep an eye on. So that will be interesting. there was one bit there when you talked about no spaces in some of the variables. Do you want to
Mhm.
just explain why that's important and how it
Sure.
helps your final Java
Yeah.
code?
Most programming languages, with Java is no exception, won't accept spaces in attribute names, class names, etc. So, unlike the code generator in Sparks, if you just generate code from a class diagram, it will just generate spaces, and then the code is not going to be functional. So, what the code generator does for the decision table is it replaces any spaces in the class name with underscore. Now, which is not a big deal. I mean, you saw an example of that with quotation underscore data in the operation, which I used in the state machine. By not using spaces, it just makes sure that your Java classes have exactly the same name as the items in your DMN model. Otherwise, there's a slight difference, and it may cause a little bit of confusion when you come to do the Java code in the executable state machine.
And I think it's just great programming practice to keep them all the
Absolutely.
same. And
Yeah,
whenever you get a
it is.
computer to guess what the variable is, there's a chance for it to have a problem.
Yeah,
So it's
yeah,
always great to remove
um,
um,
yeah.
any issues. If someone wanted to get hold of you to give, more one-on-one training, or
Oh, right.
um,
Yep. Yeah.
how would they get in contact with you?
Okay. They would have to go through the company I work for, Dunstan Thomas. I believe, I don't actually send queries to the company. I think it's called info@dt-dthomas.co.uk. But if you did a Google search for Dunstan Thomas UK, it will come up with the website. On there is a section on the website for training consulting, and there via that website you can fire off queries for corporate training and so on. So we do online training, VLE training. We also do preset EA training courses in virtually every aspect of EA you can possibly think of. We do notation training, and we also do services like building MDGs for clients, automation code and things like that, scripts. So yeah, just do a Google search for Dunstan Thomas, and then you will find our homepage. And via the homepage, go to consulting, and then you will be able to contact us.
And we can add details when we publish this on
Sure,
sparksystems.com with the
absolutely.
PDF you mentioned,
Yeah,
to make it
indeed.
nice and easy, so that the links, the hyperlinks, and the PDF and the video of this webinar
Yeah,
is all in
and
one
I'll also
location.
put my work email in there. So if anybody wants to contact me by email, I can also pass that on to the relevant parties within Dunstan Thomas.
Excellent. Well, just conscious of the time, I'd like
Yeah,
to thank you very much for a great presentation, Phil.
you're welcome.
The only other thing I wanted to ask before we go is that, what are some of the business values and what are some of the benefits that you see of having all of this process automated in Enterprise Architect? And could you talk to that possibly?
Yeah, by simulating it, okay, you'd have to use Enterprise Architect to do it, but you could actually verify to stakeholders and clients that the business rules actually work. So you could have like a session to say, okay, let's brainstorm the business rules, work through the simulation, exercise a few data sets, and people say, oh, hang on a minute, that's not quite right because that combination's wrong. So it's a much more interactive way of developing and honing and fine tuning the business rules to make sure that all bases have been covered. So I see that that's the value of doing it. Yes, you'll need to do it via EA, but to be honest, that may not be a bad thing, actually.
Yes. And look, sometimes I think it's really good for you to be able to bring stakeholders in and say, well, if we
Yeah,
increase the cost by 100, what's that going to do to our decision
Yeah,
rules, and you can
exactly. Or the
have
what if
interactive,
analysis.
yeah,
Yeah,
what if
absolutely.
analysis, and it really
Yeah.
helps you drill down in a
Mm,
cost-effective way.
yeah. And for developers, yes, they could use the Java code as is. There's no real problem. Of course they can to save a bit of development time, but it does give the developers an understanding of what should be there and the testers of the application. So once the application has been developed, incorporating the generated code, for example, then using that decision table, they could use exactly the same input data sets to test their data. So you've got the test data already created for you for the end application.
Absolutely. Well, thank you very much for a great presentation, Phil. It's
You're
been
more
great
than
to
welcome.
join you tonight, and got
Yeah,
to use my lucky number 7 in picking
yeah,
my data set. So that's great.
that's okay. Yeah, I was confident they all work.
So I'd like to thank everyone for their attendance. Thank you very much for your time. Take care of one another, and have a great morning, day, evening, wherever it is in your part of the world. And thanks very much.
Yeah. Bye everyone, and keep safe.